Hi everyone, and welcome back to part 2 of our series on building with Google's agent stack. In the last video, we set up our entire project environment, deployed our social media application, and built our very first agent, the Planner agent, using the Agent Development Kit. We learned how to define its instructions, give it tools like Google Search, and test it using the ATK Dev UI. Today, we'll dive deeper. We'll explore how to integrate our agent with existing services using the Model Context Protocol, or MCP. We'll design a much more sophisticated agent that performs a complex multi-step task with its own internal logic. All right, let's talk about Model Context Protocol, or MCP, what it is and why do we need it. We built an agent that used tools provided by ATK, but in the real world, you want to use tools from many different sources, your own APIs, third-party services, and so on. MCP is an open standard that defines a common language for models to discover and interact with any tools, regardless of who built it. MCP works on a client-server implementation. The MCP server is like a toolbox, and the MCP client sits with the language model. The client asks the server what tools it has. The server must implement a way to list all the available tools, and the model then decides which tools to use, and then the client sends the execution request. The server will have an endpoint to receive the request, and yes, the server is responsible for executing the tool. In our scenario, our demystify platform already has two API endpoints, create post and create event. We'll wrap them in an MCP server. This demonstrates how to convert an existing API to a tool for an agent to use. First, we create a wrapper for each API endpoint. We'll do that as a Python function. Basically, as you can see, the wrapper calls the API endpoint. With the wrappers ready, we can implement the MCP server. It needs two main endpoints. These tools and call tools. Now, instead of deploying client and server inside a single instance, let's build and deploy our MCP server to Cloud Run as a separate standalone service. With the server running, let's build the client. The client logic will live inside our platform integration agent. First, we point our agent to our deployed MCP server's URL to retrieve the list of the tools to ATK's MCP toolset, which will retrieve the list of tools from the MCP server. And we define another ATK agent, and this time, for its tool, we'll use the MCP toolset we just retrieved as the tool, and in this case, it's create post and create functions. Now, let's test it in ATK Dev UI. Go to the top left corner, select the Platform MCP Client agent. In the chat, let's enter a generic post. You can see the agent correctly identifies that it needs to call the create post tool. If you refresh the demystify platform, you'll see the new post. We can do the same for creating an event, or it will identify create event as tool to use, and it works perfectly. This shows how you can use MCP to expose your existing service as tool for your agent. Now, let's explore a more complex use case, our social profiling agent. Our goal is to analyze a user's friends to find shared interest. We can create tools to query our spanner database for a friend's attended events, posts, and connections. We could just give all these tools a single agent, but what if our workflow is more complex? ADK allows you to orchestrate multiple sub-agents within a single runner. These sub-agents can run sequentially, in parallel, or, as we do here, in the loop. For our social profiler, we'll create the 3 sub-agents. First, the profile agent. It's actually the workhorse that pulls all the raw data about the friend. Here we are putting in different functions that contains the graph query to analyze the structure of the network and uncover deeper insights. And let's add the profile agent, in this case, the sub-agent that will have access to the tools. Next, we have the summary agent. That takes the raw data that we have just pulled and generate a concise summary. Last, we have the check agent, which checks if we have completed the profiling process for all the friends. That's because we'll be asking information on multiple friends to go out. To implement the loop, we will need to define a check condition to see when to exit the loop. See if there are more friends to profile. If yes, it loops back. If no, it exits the loop. Things can get very messy with the loop workflow. I want to make sure we are providing the user the finalized result, so we'll use the callback. Callbacks let you inject custom logic into agent's execution flow. Here we use it to clean up the output and place the most recent results in the final summary. And then we want to define the actual workflow agent that does the loop. Remember to always set the max iterations to prevent accidental infinite loop. Let's test this dev UI. We'll ask to profile Mike and Bob. What's interesting is that with the newer models, it's smart enough to parallelize the work. It calls the profiling tool for both friends in a single turn, summarize the results, and then check agent to confirm if we're done. The final output is a combined summary of both friends' interests. Looking at the trace, you can see the entire complex flow. This demonstrates how you can build a powerful multi-step workflow agent with ADK. So where are we now? We have 3 powerful independent agents. First, the planner agent that can search the web. Second, we have the platform agent that can talk to our application's API through MCP server. Third, we have a social profiling agent with a very complex internal workflow. But they're all working in isolations. So how do we get them all collaborate and work together as a team? This is a challenge we'll solve in our final video, where we'll introduce the agent-to-agent protocol, build an orchestrator to manage all our agents, and then deploy the entire system to production. Thanks for watching. Remember, you can always try this example yourself. See the link in the description to access the workshop instruction. And I will see you in the final part.